Sorry about that. The program just stopped working. So number 5, cos of theta minus tan of theta squared equals 1 minus sine theta over 1 plus. The question does not, did I ask? The question says, give the value of the variable for which the identity are not valid, undefined. Okay, they did not ask you to solve the identity. They asked you to prove the identity. Then we have to prove the identity first. Okay? But that was not the question. Alright, so let's look at this quickly. Is there a tan? Yes, so what's the first thing we write down? Theta is equal to 90 plus k times 180. Why do I write this? Because of the asymptotes. Yes. What else can we say? Because of theta is equal to 0. The cos of theta is equal to 0. So the cos graph starts there. So it's, where's cos 0? At 90 and 270. Is that accounted for in that equation? Yes. So I don't write that. What else can we say? It's where 1 plus sine theta is equal to 0. So, this is where sine of theta is equal to minus 1. So this sine minus 1. And what's your theta value here? Your sine is minus 1. 270. So what do I write here? Theta is equal to 270 plus k times 360. Not so. But is that not accounted for here already? Well, if k is 1, then what do I have? 90 plus 1 times 180, which is 270, which is accounting for this already. So do I have to write that down? No. So what's my answer? Just that. This is my answer. Where k is an element of indeed. Okay. Let's choose another one. Choose another one. Did you guys get the picture? Number 8. Number 8. So we've got tan of beta minus sine of beta over sine squared or cube beta is equal to 1 over cos beta into 1 plus cos beta. Right. Where do I start? Is there tan? Yes. So what do I write down? For tan, it's going to be beta is equal to 90 plus k times 180. Right. So it's also we sine cube of beta is equal to 0. Take the cube root, sine beta is equal to 0. So that's your sine graph. Not so. We sine 0. Sine is 0 at 0 and 180. Is that accounted for there? Is it accounted for? Do I get a 0 there? No. You put k to be 0, I get 90, k to be 1, I get 270, k to be minus 1, I get minus 9. So I'm not picking up 0 and 180. So do I have to write it down? Yes. Okay. So that is simply going to be beta is equal to 0 plus k times 360, or x is equal to 180 plus k times 360, or this solution happens every how many degrees? 180, so it's k times 180. Okay. So that is that. Then if we look at this part of the equation, it is where cos of beta times 1 plus cos of beta is equal to 0. Can you see that's now your quadratic? Okay, or your 0 factor we can apply. So that's simply going to be where cos of beta is equal to 0, or where cos of beta is equal to minus 1. So we take minus 1, 1 and 0 to the graph, the cos graph. So where's cos 0? At 0 and at 180 and 270. Is that accounted for? 90 and 270, is that accounted for? Yes, where? It's accounted for here already. So I don't have to write that down. Can you see that, people? Where is cos of beta equal to minus 1? Is cos of beta minus 1? At 180. Not so? Is that accounted for? Yes. Yeah. Because if k is 1, then I will get beta to be 180. Can you see that? Otherwise, you could have written beta is equal to 180 plus k times 360. You could have written that. But since those are already counted for in these solutions, we don't have to write it down. Make sense? So, what do you notice here? All the solutions here. Just look here. Here's a 0. Then I'm having 90. Not so. Then 180. Then 270. Then 360. If k is now 2, 360. Then 540. And so on and so on and so on. Not 540, sorry, 450. If I go to k to be minus 1, then I get minus 90, minus 180, minus 270, minus 360. So what do you notice here? That every 90 degrees is a solution. Not so. So instead of even writing it as 2 branches here, I can just write it as 1. I can say that beta is equal to 0 plus k times 90 degrees. Okay. And again, people, if you can't see it like that, no problem, you write the branches for everyone. You get still 3 marks or 2 marks. Okay. Provided you don't forget that k is an element of integers. That must be said. If you leave that out, of course you're not going to get your mark full, your full mark full. Make sense, people? So do another one, you guys understand? Huh? People, do you guys understand, or must I do another one? Right, which one of this exercise you want me to do? Didn't we just do that number now? Or number 9? Okay. Right, where did we start? Let's just do this one together. Where did we start? Sorry? X is equal to 90 plus k times 180. Why? Because of the tan asymptote. Okay, so that is sorted. Next. What do I do next? Sorry? The denominator is equal to 0. So it's going to be cos x times sin x plus cos x is equal to 0. So how do I solve here? Can I divide by cos x? No, I will be losing a solution. You never divide by variable. So what do I do here? You factorize. You take out cos x as a common factor. I'm left with sin x plus 1. So what do I do now? So cos x equal to 0, yes? Or sin x is equal to negative 1. So what do I do now? 1 minus 1 and 0 goes to the graph. So where is cos equal to 0? 90, 270. So how can I write that? I can say that is going to be x is equal to 90 plus k times 360, or x is equal to 270 plus k times 360. Or it can be written as 1. It can be written as x is equal to 90 plus k times. The solution is happening every 180 degrees. Not so. So it's exactly that solution. Do I have to write it? No. Let's look at this graph on the side. Sine graph. The sign starts there. Where is sign equal to minus 1? 270. Is that not accounted for here? Yes. So the answer is x is equal to 90 plus k times 180, where k is an element of. Okay. For homework, I would like you guys to do the remainder of exercise 7.13, and that's on page 251. That's basically the last exercise on trigonometries. So for Monday, I would like you guys to have completed I think the revision exercise you should have started on already. Not so? Remember I told you can do all the sums of the revision exercises. You can do numbers 1, 2 to 11, I think I gave you. Did I give it to you? Yes. Okay. So now you guys can just complete the revision exercise for Monday. Sorry? Sorry? You finished it. You did it already. Did you answer those questions? Is that your assignment lying here? No. You didn't hand it to me. Did you hand the assignment? Did I give it back to you? Huh? Alright. Alright, so then leave it at this point. We'll just wrap this up tomorrow, and then that will bring us to the end of trigonometry for the year. Okay? And I'll stop this video at this point. We're going to do some financial maths, okay?